Welcome, everyone. Today we're going to talk about something that separates amateur express applications from production grade ones, and that's how you handle data validation. So here's the reality. Every single piece of data that comes into your API from the outside world is suspect. It could be missing fields, wrong types, malicious payloads, you name it. So your job as a developer is to make sure that none of that garbage ever reaches your database. So today we're going to look at Joi, Joi, and it's the most powerful schema validation library for JavaScript. And more importantly, we're going to learn how to wire it into Express as middleware so your route handlers stay clean and your validation stays bulletproof. Before we look at the solution, let's understand the problem. So if you look at the left side here, this is what's called an anti-pattern. You've got your controller functions, and right at the top, before you ever get to the actual code, you've got a line after line of if statements. Is the name there? Is it long enough? Is the email valid? Right? All of these different things. So by the time you hit line 10, you've written 20 lines of validation checks, and you still haven't done anything useful. The actual business logic, creating the task, that's way down on line 12, is buried underneath all that defensive code. Now let's look at the right side. That's the goal. 5 lines, pure business logic. You create the task and send the response. Done, right? So the question is, how do we get from the left to the right? Where did all the validation go? It didn't disappear, it moved. And that's what the whole presentation is about. The bottom line here is that the anti-pattern violates what's called dry. It's fragile because you're bound to miss an edge case, right? And it's a nightmare to maintain when your data requirements change. So here's the strategy, and I want you to think of it as the gatekeeper. When a request comes in, say somebody, registers a new user, right? Endpoint and some JSON body, right? Before the request ever touches your controller, right? In our case, we're using routes, right? Bug routes, user routes, etc. So, but before it ever touches that, it has to pass through the gatekeeper first. The gatekeeper is our Joi validation middleware. So the middleware does 2 things. If the data is valid, it says you're good, go ahead, and passes the request along to the controller. If the data is invalid, bad email, missing fields, whatever, it rejects the field, it rejects the request right there with the 400 bad requests. The controller never even sees it, okay? This is powerful because it means your controller never has to question the integrity of the data it receives. If the request made it to your controller, you know the data is clean, you can just trust it and focus on your business logic. That separation of concerns we're after. So validation is its own job. Business logic is its own job. We don't want to mix them. Now let's look at a little bit of code here. So the first piece of the puzzle is defining what valid data looks like. In Joi, we do this with schemas. So here's a schema for user registration, okay? And I'm not saying this is the exact one we'll be using for our lab assignment, but it's somewhat similar, right? But we call the Joi object, right? G.object, Joi.object, open and close parentheses, and tells Joi we're expecting a JSON object. Then inside, we define each field and its rules. So we do for a email, we do Joi.string.email.required. So that obviously tells you that that field is required in the request. So that's 3 rules chained together, right? Instead of checking to see if the request is a string, if it, is a type of, if it passes an email validation, right, has a @ sign, etc., right? All three of these things is taking care of that and making sure it's there, right? It's required. So all three of those, string, email, required is three different things, right? It's all chained together. So it must be a string, it must be a valid email format, and it's mandatory. So think about how many lines of a manual if statement that one line replaces. So you need to check if it exists, check if it's a string, etc., right? So Joi does all of that in one readable, chainable line. And then like the next one here is password. So in this one, we're also expecting it to be a string with a min length of 8, and it's required. And then the role, okay? Then we can have a number of valid allowed values, right? In this case, it had admin, developer, QA, right? Ours is going to look a little different than that for our assignment, but you get the gist of it. So, notice how readable it is. You can look at the schema and instantly understand the contract for this endpoint. What fields are expected, what types you need, what types they need to be, what constraints apply. It's kind of self-documenting code. So let's put this side by side so you can really, see the difference. String length validation. Look at the manual way. You have to do all of that. You have a min and a max. It's beautiful, right? Email format. Usually you got this long regex expression to test your email. For Joi, you can just do joi.string.email. Now, obviously, there's sometimes you may have some other specific things that, can be a little more complicated. But as far as from a standard perspective of a standard looking email, a string, a min, a max, very, very simple to do the Joi way. Then also you have optional as well. Okay, so you can state that something's optional. The engine, the validator factory. So now here's the real magic, the engine that makes everything work. This is a TypeScript file. You could call this what you want, right? But what I have here is called the Joi validator.ts file, TypeScript file, and it contains a single function called validate. And notice something important about this function. It's considered a high order function. It takes a schema as input and returns a middleware function. That's the factory pattern at work, okay? This gives it a blueprint and it manufactures a custom gatekeeper for that specific schema. So let's walk through it. So line 1, validate accepts an object schema from Joi. That's the schema type. Line 3, it returns a standard express middleware function with the request and response and next. Line 5, all right, let's see. Line 5 is where the work happens, the schema.validate. With the request body and the options, we pass in the request body and our configuration options, and Joi gives us back two things: an error object if validation failed, and a value object containing the validated sanitized data. Line 7 through 8, if there's an error, we handle it, return a 400 response. Lines 9 through 11 here. If there's no error, we do two critical things. First, our request.body equals value. We overwrite the raw request body with a clean validated version. Then we call next to pass control to the next middleware or the route handler. And I will go into, I believe in my last video, one of my previous videos, I said I was going to go through that. And I will be going through that this week. So we're going to kind of talk about that in a little bit more detail, because originally when I was going to go through that, we weren't doing really any middleware stuff, but this The next function is very important with relation to middleware. So we'll be talking about that more this week. So one function, right? It powers every single route in your application. You write it once and you're done. You pass in the schema. It's going to take care of everything. All right. So this is a high order function. Critical configuration. Now let's zoom in on those configuration options because they matter more than you might think. These two settings are doing real work for you. First, abort early, okay, false being false. By default, Joi stops at the first error it finds. That means if a user submits a form with 5 problems, they fix one, resubmit, find out about the second one, fix that, resubmit, on and on, right? So that's a terrible user experience. So if you, by setting abort early to false, tells Joi to collect all validation failures and return them at once. Now the user sees everything that's wrong in a single response and can fix it all at once, right? It's much better implementation. Second, strip unknown true. This is a security feature that's an important one. Let's say your schema expects email, password, and role. But what if someone sends an extra field? Say, let's say something like, is admin is true? Hoping your code will blindly save it to the database. That's called a mass assignment attack. And it's a real vulnerability, okay? So with strip unknown true, Joi automatically removes any fields that are not defined in the schema, okay? So in that example, is admin equal true that I was stating? It's gone, right? It never makes it past the middleware. Your downstream code only sees the fields you explicitly defined. Data sanitation and coercion. So here's something that a lot of people don't realize about Joi. It doesn't just validate your code, it cleans it too. So let's look at this example on the left. The raw request body comes in with age as a string, 25. Because remember, everything that comes in over HTTP is technically a string. And the name has extra white space, okay? Space, Alex, space. After Joi processes it, the age has been coerced from string 25 to the number 25. The name has been trimmed to Alex. The data on the right is clean, typed correctly, and ready for your database. This happens because of the line we talked about, the request.body equals value. So we're not just using the original raw data anymore. We're using Joi's validated and transformed output. So by the time your controller destructures the request body, everything is exactly the type and format you expect. This is a subtle but incredibly valuable feature. It means fewer type-related bugs downstream and cleaner data in your database. The feedback loop, structured errors. When validation fails, we need to tell the client exactly what went wrong. And we need to do it in a consistent, structured format that the front-end developers can actually work with. So here, our code handling code, in our error handling code here, we take the error details away from Joi, which contains an object for each validation failure. And we map it over to extract just the human readable message. When we send the 400 message response with the JSON body that has a status, a type identifier, an array of error details. So look at the client view at the bottom. The response comes back HTTP 400 request with a clean JSON body. The errors array contains messages like email must be valid, the password length must be 8 characters long. This is actionable feedback, right? A front-end developer can take the array and display each message next to the corresponding form field. An API consumer can parse it programmatically, and it's consistent across every endpoint because the same middleware generates it. So compare that to the manual approach, where every route might format errors differently, some returning strings, some returning objects, some forgetting to include details at all, right? Consistency matters. Integrating, injecting the middleware. All right, we see how it comes together in the actual code, right? Um, this is, a little snippet of the user routes one. At the top, we import two things: the validate function from our middleware file and the register schema from our schema definitions. Then, then look at the route definition, router.post, right, /register. Then we have the validate register schema, okay? Then we have the user control.register, right? Well, we're going to be doing things a little bit different than this, but, it's important to, the most important thing is the validate.register schema here, okay? So see how the middleware sits physically and logically between the route path, right? So what happens is basically when you have your validate within your path like this, and we start out all of our different API calls, right? Like with a router.post, whatever you called it, right? Post or get or whatever, right? So if the validation fails, okay, it's not going to execute any of that code within that, right? Within that function, okay? So, we have multiple different routes, right? So when you're viewing it, you can instantly see which endpoints have validation and which schemas they use, right? It's very declarative, it's very readable, it's just much simpler and cleaner, right? And if you need to change the validation rules for registration, you go to one place, right? The schema file. And then every route using that schema picks up that change automatically. Advanced validating URL parameters. Now, Joi handles request bodies beautifully, but there's another attack service we need to protect, and that's URL parameters. So in this scenario, let's say someone hits a get API users 123 invalid ID, just throws an invalid ID. That's not a valid Mongo database object ID. If that string makes it all the way to your database query, Mongo database will throw a cast error and your server crashes, or at best it returns a 500 internal server error, right? So the fix is another middleware, right? Valid ID. Same pattern as our Joi middleware. It's a factory function that takes a parameter name like user ID and returns a middleware function. That middleware checks if the value in the request params is a valid object ID format. If it's not, it returns a 400 immediately. If it is, it converts the string to an actual object ID, right? And calls the next, okay? The key insight here is that we're catching the problem at the gate, not at the database. By the time the database query runs, we know the ID is valid. No more unhandled exceptions from bad URL parameters. Composition, chaining validators. So here's where the middleware pattern really shines. It's composition, right? Where you can chain multiple validators together on a single route. Look at this patch route here. For updating a user, we've got 3 middleware functions in a sequence. First, validate ID. Checks that the URL parameter is a valid object ID. Second, validate upstream user schema. Checks that the request body contains valid update fields. And third, the actual controller function runs the update. Okay. Each piece has one job. The ID validator doesn't know or care about the body. The body validator doesn't know or care about the URL parameter. The controller doesn't know or care about the validation at all. So each link in the chain does its one thing and passes control forward. This is the composability that Express middleware gives you. You can mix and match these validations in any combination. So a get route that takes an ID, um, just a valid ID, a post route with a body, just validate, right? A patch that needs both, right? Chain them together. The pieces are like Lego blocks. And if you need a third type of validation, say maybe like checking the authentication headers, you just build another middleware and snap it into the chain. The pattern scales very well. So in summary, the impact of the Joi middleware. So let's recap the transformation. On the left-hand side, what we had before: scattered if-else logic in every route, inconsistent error messages depending on which whatever the developer wrote at that point in time, right? Especially when you're working on a team with multiple developers, a lot of times you're not the only person updating that code, right? So there was no data sanitization, and you had kind of bloated code where you could barely find the business logic. So on the right hand side, what we have now, the Joi middleware, centralized schema definitions that serve as a single source of truth for your data contracts, standardized JSON error responses that every endpoint returns the same way, automatically stripping of unknown fields, and type coercion. It's pure business logic. Separation, right? So this is what production ready validation looks like. It's not just about catching bad data. It's about architecture. It's about separation of concerns. It's about writing code that's maintainable, months, if not years from now, when someone else has to change the validation rules. Okay. So that's all I have. Thank you very much. And in the next video, I'm going to be going through a lab assignment showing you the actual code for implementing the Joi middleware. Thank you very much and have a great day.